Disclaimer: defacing U.S. coins with fraudulent intent is illegal. Although this may look illegal, it is not, because I will not be trying to get any money from the resulting nickel metal. And there are no sanctions against defacing currency without fraudulent intent. Alright, let's just see what I've been doing for the last 2 months. Hey everybody, welcome back to BackMacSci, and in today's episode, I'm going to show you how I thought I'd get nickel metal out of a nickel coin. And my reasoning was that 75% of a US nickel is copper, but the other 25% is actually nickel metal. So I figured I'd be able to pull out the nickel metal of the nickel coin and put that in my element collection. Alright, so here's the equation I'm going to use, and it reacts nickel metal with hydrochloric acid, and because I'm cheap, I only want to use 100 milliliters of hydrochloric acid. So if we calculate how much nickel that can react with, it actually turns out to be around 20 grams of nickel metal. And to figure out how many coins that is, we just use some more dimensional analysis, and it turns out that we can react around 16 coins. But in order to make sure that I can dissolve as much nickel out of the coins as possible, I'm only going to use around 15 coins worth of nickel metal. And that's only going to cost around 75 cents US. Alright, let's try to go dissolve those 15 coins. Alright, so here's the supplies we're going to need. Aluminum foil and other aluminum sources. Hydrochloric acid, mine's around 6.8 molar. 15 nickels, as I said earlier. Round bottom flask for refluxing, a beaker to hold the reaction in, and a magnetic stirrer that can also heat. So first I measure out the 100 milliliters of hydrochloric acid, and next I add a little water to the round bottom flask, and that'll help condense the hydrochloric acid vapors that come off of the boiling hydrochloric acid. I add the hydrochloric acid filled beaker to the hot plate and add a coin in order to dissolve the nickel out of the coin. It starts bubbling, and that's pretty promising, but it turns out it's not actually hydrogen gas. We'll figure out why later on. Once I added a few more coins, I let the solution boil for around 3 hours total, and I added a little more hydrochloric acid later just to see what that would do. This green color was developed because I added some hydrogen peroxide, and I figured that would help dissolve the nickel, but really it just helped dissolve the copper out of the coins. As we can see here, there's a pretty green solution because of the dissolved copper, and also a little bit because of the nickel. And what we're going to do is remove the coins from the mixture by filtering. Just a gravity filter, I don't have anything fancy. And what we're going to do with this green solution is react it with aluminum in order to perform a single displacement reaction and form nickel metal, or at least that was the hope. So as I add my first lump of aluminum, I see some promising hydrogen gas, but in reality this is just the aluminum reacting with the excess hydrochloric acid that didn't actually dissolve any of the US nickel alloy. At this point we have a suspension of blackish aluminum and copper particles, and as you can see here, as I let it sit, the copper begins to settle out and not much nickel is seen. So I figure, you know what, I'll just add more aluminum, see if any nickel happens to precipitate out, and turns out none did. It was all just copper, and no nickel actually dissolved in the hydrochloric acid like I thought. Anyway, I still tried to filter out this precipitate, and as you can see, a few days later it took on a greenish color like an oxide of copper would. And so I did the only thing that I thought I could at this point, which is do a flame test in order to determine what metals are present in a mixture of metals. So I took a little sample and I looked in Wikipedia, and it said nickel usually had a silver white flame. So I tried to look for that when I did the flame test. It turns out the emission spectra of this powder is pretty damn similar to copper, so yeah, that's not nickel. Let's talk. Hey guys, it's Mac. So let's discuss the results of this experiment. Alright, so why did this fail so badly? What I thought when I decided to get nickel metal out of nickel coins is that, oh, it's just a crystal structure with copper and nickel in it. And I thought, oh, I can selectively remove the nickel atoms out of the crystal structure, and I'll just leave like a weakened lattice of copper, and the coin will just lose some mass, and the lost mass will turn into nickel ions in solution. And then I'll react that with aluminum and get it back as nickel metal, because aluminum is more reactive and a single displacement reaction rate. And then I'll have nickel metal for my element collection. Turns out that's not the case. So what we learned from this today is that you can't selectively remove a metal from like this very corrosion resistant alloy. I wish it worked too. All right, see you later. I'll see you in another episode of BackMacSci. Peace.